These notes are molar dilutions. Okay, sometimes we need to dilute concentrated solutions. To do this, we need to use a dilution formula. And it's going to kind of look like Boyle's law in a way, because it's M1 V1 equals M2 V2. Now the M is your molarity, and your V is your volume. Now, one of the things when you're doing dilutions, there's two key things to keep in mind when you're doing the dilutions to check your answers. First off, M1 has to be greater than M2. Okay? If it's not, because you're diluting it. So when you dilute it, you're having less and less moles per liter. Okay, you're increasing the volume. So your molarity has to go down, otherwise you're doing this wrong. Next, your volume, your V1, must be much less than V2. You're adding water. That's how you dilute it. So your volume should go up in the end. If it doesn't, there's something wrong. Okay, so those are two key facts. Now, doing these dilution problems, just like with Boyle's law, you've got to rearrange the variables. So I'm going to go ahead and do that for you. So, oops, didn't want to put a mark in the middle of the... Hang on, let me erase my little mark there. Okay, let's move this up a little bit. Okay, so we're going to do M1. We're solve for M1. Now, when we do that, we're just going to move V1 over to the other side. So your M2 V2 stays the same, and when, of course, when it goes on the other side, it goes underneath. Okay, so you're multiplying it on the left-hand side. You need to be dividing it on the right. Same with the V. The M2 V2 stay the same, but the M1 goes underneath. We're going to do the same for M2. The M1 V1 stays the same. V2 goes underneath. For V2, M1 V1 stays the same. M2 goes underneath. Okay? So just make sure you write down these four equations somewhere on that sheet that I gave you. Or just memorize how to do it. Okay, how much 12.0 molar HCl is needed to make 125 mils of a 3.25 molar solution? Okay, just like with the gas laws, guess what we're going to do? We're going to define our variables. So M1 is 12.0 molar solution. V1 we don't know. M2 is 3.25 molars, and V2 is 125. Now, if you're getting mixed up as to which molarity goes where, well, the greater molarity goes with M1 and the less molarity goes with M2. So the bigger number, M1, smaller number, M2. And if you're given two volumes, it's the opposite. The larger volume is V2, and the smaller volume is V1. Okay, so we're going to use the equation V1 equals M2 V2 over M1. So V1 equals, and it's 3.25 times 125 divided by 12.0, and V1 is going to equal 33.9 milliliters. Okay? Okay, so what is the molarity of a solution made by diluting 25 milliliters of a 10.6 molar NaOH solution to 125 mils? So I'm going to write my M1, V1, M2, V2. Now I know sometimes you guys have issues trying to figure out what goes where. Well, rule of thumb here, remember, the larger the two volumes goes to V2. So I have 25 mils and 125. That means my 125 is my V2, my 25 is my V1. Now we're going to look to see the 10.6 molar solution. Which number is it attached to? Which volume is it attached to? And it's 25 mils of a 10.6 molar solution. That means the 10.6 goes here. And we're looking for M2. So M2 is 10.6 times 25.0 divided by 125, which is 2.12 molar NaOH solution. Okay? So that's how you tell. And then that works. I mean, if you were to do the 10.6, remember, just 10.6 is a big number. You're not going to dilute to 10.6. Generally, anywhere is between 12 to 10, even down to 9. Those are usually the molarity concentrations that are called concentrated, okay? So if you have anything between a 9 or well, between, actually, greater than 9, I should say, that's always going to be your M1. Okay, that's the type of solution. That's the concentration of the solution you're actually going to be diluting. Okay, how much water do you need to add 78 milliliters of a 10 molar NaOH solution to make a 3.5 molar solution? Okay, first off, we're going to write our M1, V1, M2, V2. Okay, so 10.0 molars, 3.50 molars, 78.0 milliliters. Oops, and we're looking for V2. Now, one of the things when you're adding water, your V2 is your final solution. Oops. So V2, well, if I could get it to erase, that would probably be better. Okay, scribble it out. V2 minus V1 equals the amount of water added. You're going to need to use that at the end once you figure out your V2. So V2 is going to be 10.0 times the 78 divided by 3.5, and that gives you 223 milliliters. Now that's the final volume. That's not how much water you're adding. You're starting out with 78 milliliters, and you've got to end up with 223 milliliters. So 223 minus 78 gives you 145 milliliters of water added. Okay? Okay, explain how to make 1.5 liters of a 0.325 molar HCl solution from a 6.0 molar HCl solution. Well, the first thing we're going to do is calculate how much of this 6 molar solution that we need. And then we can describe how to make it. Now, we're going to turn everything into milliliters. It's probably best to turn things into milliliters, because otherwise you're going to have fractions of liters. And most of the graduate cylinders that we use are in milliliters. So if I'm asking you to describe how to make something, I would go with milliliters. It's probably the safest bet. Unless I tell you otherwise. And that's a 5, by the way. Really rotten 5 over here. Okay. And then 1.5 liters, which is 1,500 milliliters, goes here. And okay, so V1 equals 0.325 times 1,500 divided by 6.0, and we get 81.3 milliliters. You guys have used those graduate cylinders. It's really difficult to figure out 81.3, so we're just going to use 81. So our final volume's the 1,500. We have to find out how much water we need, as well as how much of the original solution we need. So we're going to add 81 milliliters of 6.00 molar HCl to 1419 milliliters of water. Now, if you remember, HCl is an acid. Never add water to acid. Always add acid to water. Just something to keep in mind. That this really is your answer. Okay. What is the resulting molarity of a solution made with 108 grams of NaOH dissolved in 250 mils of water, then diluted to 1.0 liters? Now, originally I was going to show you how to do this, the dilution method, but that takes a long time, and I'm not sure you guys would understand it. I'm afraid some people would get a little confused. So we're just going to go straight figuring out the molarity, because truthfully this really isn't a dilution. It is truthfully a just straight old molarity. So we know molarity is moles per liter. So your molarity is 108 grams of NaOH divided by 40, I should put mole here, 40 grams per moles. And this gives us 2.70 moles of NaOH. Now, molarity is the 2.70 moles for 1.0 liters, which is 2.70 molar NaOH. And if we do it the dilution method, and if you guys want me to, I can show you that in class tomorrow. But if you do it the dilution method, you get the same number. I just don't see the point. It's a little confusing. And you can do the same thing, which is basically solving for molarity. Okay, guys, that's it for tonight's notes. I guess I will see you tomorrow in class. Bye.